Welcome to Rocket Ship, the home of epic React Native content. I'm Simon Grimm, and today's guest is Oskar Franco, who actually lives in Munich, fellow German, but he's from Bolivia. He's a freelance system engineer, and you are also the creator of several React Native libraries. And I discovered one of your videos about React Native bridgeless. So first of all, thanks for taking the time, Oskar.
Yeah, glad to be here.
In today's conversation, I would love to dive into new architecture. I think we haven't really covered this. I think it comes up in every React Native conversation these days, but I don't know. Most people probably don't know exactly what it is. They hear new architecture, they hear JSI, they hear bridgeless mode. And besides being excited about this, I'm pretty sure some people fear this because React Native feels stable, and now we're rolling out a new architecture that doesn't sound right. So we want to cover all these aspects, and you had some really good videos, and I think you're the expert to explain this. But before we get into all of that, maybe let's start with you and your background. So could you just tell us what's your background and like what was your path into React Native over the time?
Sure. So I studied here in my home country in Bolivia. After university, I started freelancing, and I got a lot of European clients, so to say. That's why I decided to move to Europe at some point. There, I took on several roles, did a tour of small companies, bigger companies, worked with a lot of different projects. And it was kind of accidental, my introduction to React Native. It was just because we needed a mobile developer, and I was actually kind of the tech guy of the team. Poking holes everywhere and fixing stuff. And that's kind of how I started at the beginning. Of course, painful because I'm not a native developer. I'm still not. But over time, I got a very good hold of the technology. Then at some point, when switching companies again, my focus went towards React Native, just because that was what the company needed. And a couple of years ago, I decided to go freelance. And with the freelancing stuff, the beginning is always scary. It's always painful to get the first client. And I had some free time. I was already doing React Native, and I could already see there were some holes in the community libraries and this kind of stuff, and open source and explanations. So that I just started on my free time, exploring, doing the videos, the tutorials, writing stuff. So it kind of slowly built up to the point where, some people call me a reference for this kind of stuff.
I would absolutely call you that. And I'm excited to get into all that stuff. Maybe before we really dive into like the new arc and what's new, maybe we should quickly cover like the current state or where React Native came from. So what is so for those understanding, what is the current bridge concept in React Native, the current architecture, and why do we actually have to build a new architecture? What's the problem?
Yeah, so there's a lot of confusion going on with the new arc, so I think it's great to start from the beginning. So when React Native was created, it was basically the first iteration of Facebook trying to do fast mobile development, right? So they took JavaScript, they took React, which they already had, and then they just come up with a way of creating UIs, fast refresh UIs towards the native side using JavaScript. And the first iteration of ideas is usually make it work. Don't worry about if it's fast, if it's correct, just make it work. So the way that the JavaScript updates were sent towards the native side of things was via JSON serialization. So this mechanism was then called the bridge, because everything went through this JSON serialization, right? So it's a funnel where you have JavaScript, it outputs some sort of representation of the UI, and then it just goes towards the native side. That's the basic idea of the JSON bridge. So then you can imagine as the framework grows, as the amount of code grows, this becomes a bottleneck. All right, this is slow to turn things into strings, send them to the other side, parse them, read the entire thing, yada, yada, yada. It works, but at some point you just hit a bridge of performance. And that's basically where the bridgeless re-architecture comes from. It means getting rid of this JSON bridge.
So basically, every object was called JSON stringify on the one side, and on the other side, it was like JSON parse again.
Yeah, yeah.
Yeah, I
Which is,
mean,
to be fair,
everyone just.
To be fair, is the first iteration of every single interoperability layer people come up, right? Like you see this all the time with frameworks, with different languages, with Rust, etc., etc. Whenever you need to send something between languages which are not compatible with each other, you just reach for JSON.
I mean, also people at Meta or Facebook in 2014, 2015 probably didn't think about that this would become the framework to build cross-platform applications over the next 8 or 10 years. So it was probably more like the initial solution. Okay, so that is the problem in current applications. Do all applications, all React Native applications suffer from this, or is it really only if you make heavily use of some sort of native stuff?
Well, it's more prominent if you use native stuff, because again, the scope of React Native evolved over the years, right? First, it was a way to easily build UIs, and now we're doing AI, now we're doing databases, now we're doing image processing and this kind of stuff, right? So it definitely became a problem, a more prominent problem.
And it would probably become an even bigger problem over the next few years as like AI and new stuff arrives and we like put more stuff into that bridge.
Exactly.
So you already said the word bridgeless before, and I don't know where to start with a new architecture. Should we start with a bridgeless mode and what it means? Is that probably the best transition into what the new architecture brings? I'm unsure, so let me know what you would think where we should start.
Well, I already tried to explain this in different articles and different videos. I think it's just very confusing because it's not a single thing, actually. Bridgeless is more of a concept that encompasses at least three different topics. One of them is the JSI, which is the C++ part of writing native or bridged code to the JavaScript side.
That part scares the shit out of me, honestly.
Yeah. The other part is Fabric, which is the new renderer, the new 3D renderer, which is also C++. And the last part is code generation, CodeGen turbo modules. So these three things encompass or are what we call bridgeless.
So bridgeless simply means we're getting rid of the bridge and we're using the new stuff instead. And I think you can, with the current React Native version, use this new bridgeless mode right now. Exactly?
Yeah. Yeah. So
bridgeless is... Does new arc and bridgeless mean the same?
Bridgeless is kind of one sub-concept of the thing, but so the new architecture are these three things, and bridgeless just means removing the old code. Like there's no more opportunity to use JSON anymore. So it's basically it encompasses everything. Once you talk about bridgeless, you talk new architecture, JSI, turbo modules, CodeGen, blah 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 blah. Plus, you cannot use the old modules anymore; they're gone.
I think most library authors are already working on a transition. So we can probably come back to what this means for libraries used in your application later. So let's dive into the new arc and the three topics you mentioned. Where would you like to start? JSI, Fabric, or CodeGen?
Let's start with Fabric because that's the easiest one.
Yeah, so, of course. Go ahead.
The old bridge, like I said, everything was sent via the JSON representation. Yes. But that also included your UI, right? So that also means if you have a lot of UI updates, this also gets slow at some point. And I don't know what the old renderer was called. It's just old renderer, but the new one has a name, which is called Fabric, right? And Fabric doesn't do the JSON parsing. It takes advantage of the C++ bindings and it's just a faster updated for you UI, right? So if you have a lot of set states, if you have a lot of updates, mounting, remounting components, Fabric does exactly the same. It's just C++, right? So it should be faster.
Yeah, everything that's C++ is good and fast. I heard that. Okay.
It is fast, it's just hard to write.
So the next one was JSI. What does actually JSI stand for, and what is the improvement that it brings to React Native modules?
JSI stands for the JavaScript interface. And again, the benefit that it brings is just that it's a faster binding between JavaScript and the native side of things. On more, real terms, JSI is just a bunch of functions, C++ functions, that directly interact with the JavaScript engine. So instead of doing, again, the JSON serialization, the native code parses your UI tree or whatever call, extracts the data it needs from there, you can directly interact with the C++ bindings of the JavaScript engine. So you can create objects, you can create functions and data back and forth in a much faster manner.
So how is this connection between the native code and JavaScript currently realized? I mean, currently in the old days of React Native when there was no JSI?
Mm-hmm. Mm-hmm. I don't know the exact internal specifics of how the data was injected into the JavaScript engine, right? So you basically, on the old modules, you declare Objective-C function or a Kotlin function, right? So there's a bunch of magic in there. It just takes your data, it just parses it, it creates it interacts with the JavaScript engine itself, right? So let's say internally, it used probably some similar concepts where you will just create an object, where you just create a number, a dictionary, an array, and just inject that into the JavaScript engine. But there was this middle layer of calling some private headers, some private functions, which were not exposed. JSI is basically just exposing that interfaces directly to the calling modules for React Native.
So the code also becomes more type safe.
Yes, at least the native code.
Okay, so Fabric, JSI, and the third one was CodeGen. Where does CodeGen come into play?
CodeGen tries to solve a little bit of a side problem, which is on the old modules, whenever you would create your interface, it wasn't automatically synced with the JavaScript interfaces that you had. So if you change something on the native side, you had to kind of go through this manual process of making sure that you change your JavaScript interface as well. And you can imagine with smaller modules, it's not a problem, but at scale, especially Facebook scale, errors happen, right? So CodeGen tries to solve this by saying, okay, you just declare your TypeScript or your Flow interface, and we will take care of generating the C++ code, which will be type safe and will always be updated. So if you change something, your native code won't compile. So you have more safety in there.
Okay, I try. I think I understand. So that also means that my TypeScript is then like the single place of truth, because from there on, CodeGen generates the interfaces.
Yeah.
Okay, good. I think that's a good rough overview about the new architecture, the three domains. I do have some. Definitely some questions, follow-up questions. So the first one I have is about something called the host object. I heard the host object being mentioned a couple of times, but I don't really know what I should think when I hear host object. So could you explain, is this like, what is it in this context?
Now we're delving into the very, very technical part, which if you're consuming libraries, I mean, you don't really care. The library author will take care of exposing something for you. But so the JSI, like I said, is just a bunch of headers and functions that we can call from C++. And you can imagine if you're trying to interact with a JavaScript engine, you just need a bunch of different concepts there, a bunch of different functions, right? Sometimes you might need to create an object. Sometimes you might need to create a function. Sometimes you might need to create an array, this kind of stuff. So the JSI is just ways to create JavaScript objects and scalars, right? And once you go a little bit deeper into the JavaScript engine, there might be some more complex use cases, let's say, where you just don't want to create a pure JavaScript object. You might want to create something more hybrid, right? Something that has some native state, some C++ memory manage thing, but only exposes a certain interface to the JavaScript side. right? So the interfaces can be quite simple, right? It just takes a scalar, it's just functions, but all the native functionality remains in C++. So a host object is just a way of declaring a C++ class that also is shareable to the JavaScript side of things, more or less in a straightforward manner.
That's interesting that you said hybrid, because last week I was having a little conversation with Mark Rosavi, and he tried to explain Nitro Modules to me, and they also use the term hybrid object under the hood for some of this stuff. So I feel like all the things come together and finally make some sense to me. Okay, so I heard a lot about C++, Objective-C, JSI and stuff, and all of that is somewhat really technical and maybe even confusing to the like regular React Native developer. I think this is, I don't know, it's maybe mostly interesting to library authors or open source contributors to specific packages. So let's probably also take a step upwards in general and talk about like how to migrate to the new architecture and the benefits of the new architecture. So as we said, with the current version 0.775, I think is the current version, you can use it if the modules are ready for the new architecture. But is there anything I need to do, like to migrate my app from the old architecture to the new architecture? Is that process going to be painful? And am I getting any benefits at this point?
I think right now it got a lot better. Last year it was still a little bit unstable. There were a lot of packages that used to break. For library maintainers, it's actually quite a lot of work, right? Because you need to now learn a lot of new concepts and the way that the tooling has changed, and now you need C++, and that's fairly difficult, to be honest. For the consumers of libraries and user apps, it's kind of a hit and miss. You just turn it on and see if your app explodes. Basically, there's no other way to tell you this. But there are a lot of benefits, of course, especially on the speed side, right? Because now that we're migrating to interacting with the JavaScript engine itself directly, there's a huge speed up there awaiting for a lot of apps. Like I said, it got better in the last few months because of the work of people on Expo, on the React Native core team, different companies who gave a hand to a lot of maintainers on their libraries to update them to be compatible with the new Arch. There are still libraries which are not updated. They're pretty much abandoned, right? Like they work perfectly fine in the old architecture, but nowadays they won't work with bridgeless. And that's going to be actually the biggest pain, I guess. Of course, there's a lot of smaller libraries, right? Like very niche use cases, Bluetooth or some sort of SDK that was created many years ago, never updated again. But there are probably some bigger stranglers in there. I can imagine, for example, Firebase. A lot of apps depend on Firebase, and that's a huge project. And updating such a thing, it's a lot of work. So if your app has a hard dependency of one of these bigger projects, you cannot migrate away from it, then unfortunately it's going to take some time, or maybe you want to have to migrate to some sort of other library that supports the new architecture.
I see. Do you know if anyone working on the Firebase migration?
Yeah, I mean, it's maintained by Firetaste or something, some other company that does consultancy. I'm guessing they will migrate it at some point. But in and of itself, Firebase is just such a complex project that it just takes time and a lot of effort.
So what if I'm migrating to the new architecture? I'm just starting a new project using the new architecture right now, and I want to use an old package that's probably not maintained on GitHub anymore, that's not updated to the new architecture. Is there any way to still like combine this with the new architecture and say, hey, this is like a legacy module and use it as it is?
The core team put some work to create the interrupt layer. So in theory, right now, the old modules, even though they're declared the same way and they have no idea what bridgeless is, there has been some technical work to make them just work, right? So in theory, they will use the JSI and everything, But this is an interop layer. This is a kind of a hit and miss. You can install it and see if it works. Otherwise, unfortunately, there's no way to make them work. There needs to be some migration work on the code base itself.
I feel like the next years are going to be rough for some companies if they want to adopt the new architecture because, like big projects, the dependencies and the package JSON is getting longer and longer. And then you have this one somewhat tiny or mid-sized project that's just not maintained anymore. I don't know.
Well, the good thing, there is a lot of companies and freelancers, including myself, right? Like make a living out of this because people like you know, they see the videos and it's like, okay, this guy knows how a Turbo module works, how a JSI module works. We need this for this week, right? So they come to me and I'm like, yeah, okay, this is going to take me 3 or 4 days. Don't worry about it. And so there's definitely people who can help with this at least.
Okay, that's good to know. And shameless plug for everyone watching this. If you need an expert, contact Oskar. So that brings us, that's actually good that you mentioned this, that you're into this. So, because one of my questions was, how do I create a new architecture-ready native module with JSI? You don't have to explain anything because that will probably be an hour-long tutorial. But let's say, so I know that when I have an Expo project, I can quite easily create like an Expo module, the Expo version. I know the official way is like a turbo module, but that one is pretty easy with Expo. So how do I get started with JSI? Like which files do I create? I have so much going on in my head. Could you just like roughly give us different steps if you wanted to, let's say you want to expose whatever kind of Bluetooth or device functionality and have a little native module for it? Where would you get started?
Oof, this one's rough. Yeah, so this is kind of the hardest part. If you want to do a module that you're going to publish to other people, like not internally to your app, then I suggest you go for Builder Bop, which is a package from Software Invention, I think, or it's from ColdStack, React Native Builder Bop. So basically what it will do, it will just scaffold everything for you. You can pick, okay, I want to use the JSI, I want to use pure C++, I want to use Objective-C and Kotlin. It takes care of all this stuff for you because creating it manually is just a nightmare. You don't want to do this.
I didn't expect you go through all the files. So yeah, using like a template or some scaffolding is totally fine.
So this is the package is very, very nice if you want to publish something to the outside world. If you just want to bootstrap something internal for your own app, then the documentation is fairly up to date, I think. For Objective-C and Kotlin modules, it works quite well. If you want to do direct C++ bindings, the documentation there is still iffy. They're still working on it. They haven't published anything. Yeah, and so the model creation is still a little bit rough, to be honest.
Okay. I mean that's good to know. So if I use like Expo modules, that is a lot easier, I would say.
Well, that's why there's a lot of work going here, right? Like that's why the Expo people created Expo modules because they saw Turbo modules like, nope, this is just way too hard for a consumer app that just needs a module to expose some certain native functionality, right? Like this is way too much work. You need to know way too much about the internals of React Native. I think this is also why Mark is working on Nitro Modules. That also looks very nice. It's not tied, it's not coupled with Expo because there's a lot of bigger companies that did not start with Expo and now they cannot migrate to Expo. They don't want to migrate to Expo. I think this is the major motivation for like why is there so many efforts trying to create a module system for React Native.
Yeah. Let's get into these different modules. So Turbo modules. Is this just the new way of creating native modules and a fancy new name, or did Turbo modules exist before? Maybe you could explain what Turbo modules actually means and also like includes.
No, Turbo modules didn't exist before in the old architecture. Turbo modules came with the new architecture. Like I said, one of the main benefits is this code generation step where all your types are in sync across JavaScript and native side. The other benefit of Turbo modules is lazy initialization. Again, this is something, if you have worked on a large enough React Native app, you will see that the app just takes a lot longer to start. And Turbo Modules kind of bring this lazy thing. It won't get initialized until you call it at some point in the life cycle of your app. So there's definitely some benefit of Turbo Modules. It is the official way nowadays that Meta and Facebook are working with native modules. They will keep doing this because Meta, even though it open sources React Native, their priority is their product, right? And for them, that works. That doesn't necessarily mean for the community, for all the other apps, it works for them.
So regarding Turbo Modules, and we touched on this, so Mark Rosavi, just as a quick note, is working on something called Nitro Modules. When this episode goes live, maybe it's public. Right now, it's like private beta or whatever. Many smart people say that Nitro modules might be the future of how we build native modules for React Native, because it's very smart how it's using stuff under the hood and super fast and super performant in the first benchmarks. I saw on your YouTube channel, you in the past had a lot of, a couple of videos on Turbo modules. So what is your current take on like Turbo modules versus Expo modules versus Nitro? What would be your preference right now?
Yeah. This thing, when you work at a certain level of complexity, there are no pure benefits. There's always trade-offs, right? Turbo modules have some benefits. Expo modules have some other benefits. My personal take is I always try to do the fastest possible binding, at least when using modules, just because I know that it takes away from the developer experience, but it gives the most benefit, at least in terms of, the people consuming the package, they don't care about the JSI, they don't care about host options, they don't want their module to be fast, right? And I think the trade-offs of all the different module systems, they have big different trade-offs, right? So for Turbo modules, there's a lot of steps involved regarding code generation, regarding all the knowledge that you need to have in order to create a Turbo module. So they work quite well, but setting them up is quite painful. Expo has taken a different side of, or a different set of compromises. The Expo modules are very easy to initialize, are very portable. They don't need a lot of files, they don't need a lot of knowledge. You just follow the tutorial and they just kind of work. The problem with the Expo modules, and this is probably not something that gets a lot of talk, this is something that I published on Twitter some months ago, is that because of the ease of use, they need a lot of code in between the moment you call the JavaScript function and the moment it hits your actual native function. So there is a little bit of performance goes with Expo modules. For the most apps, you won't notice it if you only call a few things. But if you're creating something like my modules or Mark's modules, right, where you're passing frame buffers, where you're passing a lot of data from the database or whatnot, this is probably not the best choice, right? At some point, it might become too slow for some hot critical path of the apps. And I think Mark now has set for another set of compromises. The work that he does is amazing, right? Like he has a lot of internal knowledge about the JSI, C++, and he's doing a lot of things. I think time will tell if there are some sides, how do you call this? Some compromises, some side effects of doing it the way that he's doing it. Maybe he just takes some extra work with the translation layers, or he will just need to continuously keep updating it to keep with the JSI changes, because it's very, he's using non-documented knowledge, right? There's a lot of community chat going on between the authors of the JavaScript engine and whatnot. But at least for now, it looks like it will be the fastest alternative. So
yeah, it certainly looks like that. Yeah,
Yeah, yeah.
from the first benchmarks, it looks amazing. And when I talk to him, I'm also in the Discord, and there are people like Jacek from Unistyles, or
Mm,
the team from Kendall Finance, which has a lot of like native knowledge, and a few authors from the community are in that chat. So it's exciting to see that they show interest in the package, and yeah, it feels definitely interesting, but also talking to him for an hour, a lot about C++ and JSI and
mm,
whatever. It's hard to understand if you're not like a native
yeah,
developer, or not. You don't live in that land. It sounds like
yeah,
this is something completely different. It's like this is game development, and I do
yeah, yeah,
apps for my grandma or so. So,
yeah.
um, yeah, you said it right. Time will tell, and I agree. There are always trade-offs. There's no solutions. There are always trade-offs. I don't know what for Nitro modules the trade-offs will be in the future. Certainly
Yeah,
not performance. Performance is what makes it stick out.
yeah,
But
yeah,
we will see.
yeah.
So one thing I'm curious about is we said it a few times that now C++ is used under the hood in like these modules and stuff. And would you say right now it's actually helpful to learn a bit of C++ if I'm a React Native developer?
Mm, I mean, it's always helpful to understand what the machine does, right? But I understand the difficulty, the entry barrier is quite high, especially because you're not diving into easy topics, right? There's a lot of internals of JavaScript engines, how memory works, and etc. etc. Uh, probably not. Probably not. If you're just consuming modules, I think it should be fine. But in
Okay.
the case you're doing, some really, let's say, interesting stuff, right? Like some computation, some interaction with some hardware, um, then it definitely does.
Okay. Yeah. I actually learned C++ like probably 20-ish years ago. It was like my first thing when I picked up a book from my
Mm-hmm.
brother, and I had like the pointers, and I still remember a couple of things from back then. But I feel like it has changed. And you are also, as far as I know, a lot or a bit into Rust. And you also had a video about like, what was it, like combining React Native and Rust in something, or
Yeah,
integrating Rust and
creating,
React Native.
yeah,
Um,
creating a
could
Rust
you let
module.
us know like what? I actually don't know a lot about Rust. I just know that it's quite fast. So
Yeah.
how are you using Rust in the context of React Native, and probably also why?
Mm-hmm. Mm-hmm. So we are reaching a certain point where a lot of apps and a lot of tooling is being written in Rust. The benefits of Rust are, you can Google them, right? Like memory safety. There's a new language, a lot of community. It has a lot of integrated tooling inside of the compiler, inside of the package itself. So it's kind of the tool for the next decade or the next couple of decades, let's say, right? Like a lot of lessons learned. It's not perfect. It has some downsides as well. But even the U.S. government is now saying we need to rewrite stuff in memory safe languages. Pick your poison, Go, Rust, whatever. So let's say it's here to stay, right? And React Native solves a lot of problems when doing app development. Rust solves a lot of problems with doing development, right? And this is a big selling factor for a lot of companies, like critical software companies. You want to eliminate all the memory safety errors. You want to have better tooling, etc., etc. So the reason I got into doing more Rust wasn't because I chose to, because for native development, the need wasn't there until now, right? Like most of the modules we used were just bridging native APIs into JavaScript.
Right.
But now that we kind of have overcome that threshold, let's say, we have a lot of modules, most of the native stuff you can access from React Native, from JavaScript. Now there's a lot of companies who are thinking, okay, React Native is stable enough. This is a big platform. We want to make our SDK available to them. And most of the new companies, so let's say most, but let's say a lot of companies now are writing their SDKs on Rust, because all of the benefits of that Rust just provides, platform agnostic, memory safety, yada 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 yada. So now we're reaching this wave of companies who are like, okay, we have our SDK, we want to make it available to React Native. What do we do? And that's how a few companies contacted me, especially since mid of last year, where they're like, hey, we have this, we need your help. How can we do this? And I was like, I don't know, but I can find out. Right? So I talked with a few members of the community who had successfully bridged Rust into React Native. I started there and then just started learning Rust, right, on the one side, because I didn't know any Rust. And then just kind of adjusting the tooling, seeing what's possible, learning on the pathways. So that's where you see all the articles that I write, all the videos that I do. It's just me learning this stuff. Like, okay, how do I compile this thing? No idea, right? And after some months, it's like, okay, this is how you compile it. It took me 3 weeks, but here's the command. Don't worry about it.
And so then you're able to bring in like the Rust SDKs into React Native through the new architecture somehow.
Yes.
Fascinating. I didn't know that was possible already, and I heard a lot of good things about Rust. I think isn't the Primogen also a big fan of Rust? I don't know.
Yeah.
Either of Rust or of Go.
Rust, Go, and Sig are his new things, I think.
Okay, so I will definitely keep an eye on Rust. Yeah. The only thing I got in touch with the Rust was actually there was a cross-platform solution. I think it's called Tori. I don't know. Have you tried Tori? That's based on Rust?
I am. I am in the middle of a project and mixed experience, let's say.
Mixed experience.
Yeah. Well, the thing with Tori is it's similar to React Native. It tries to solve the problem in a similar way, right? Like nobody wants to write native software because you write it twice, thrice. So again, it's an idea of, okay, let's build as much as we can with JavaScript and just bind whatever native functionality we need. The thing starting with Rust and coming from React Native is all the lessons learned. Tori is a much smaller project supported by a much smaller company with a smaller or with a shorter time span. So they didn't have the time or the community to solve all the problems that we have solved on the React Native space, right? Like we have moved from a JSON bridging to now native bridging. We have solved, so many issues with the native rendering and this kind of stuff. Expanded into different L3 platforms, using React, using different architectures. And Tori doesn't have that yet, right? So there's a lot of holes in the documentation. There's a lot of holes when it comes to functionality that has been exposed where it doesn't behave the way you expect, and so on and so forth. So it's not a bad idea, right? Like it's kind of a smaller electron, let's say, when it comes to memory, to footprint, et cetera, but you can see that they are solving the same problems that we solved with React Native in the same painful way, right? Like you build it, it's slow, you spend 6 months fixing it, et cetera.
Okay, I see. So yeah, it was always on my list to get into it, but now I might shy away from it. Yeah, I thought the idea sounds great, but it's good to have some insights from you using it, and that it's probably not yet there, and I don't know if it will ever be there. So, to wrap it up for today, I just want to quickly talk about one library that one open source library. I think this is OP engineering is the OP exactly. SQLite package, basically. Is this your biggest library, or do you have other libraries with even more stars?
Library, yeah, I think that's the biggest.
So this is, at least you claim, the fastest SQLite library for React Native. And I'm curious. I think Expo recently did like a new SQLite version and said it's quite fast. And then I know that, of course, MMKV claims to be the fastest, but MMKV and SQLite are still a bit different things to me. However,
Yeah.
your benchmark says that OP-SQLite is the fastest in town. So why did
Mhm.
you create another SQLite library, and why is it so fast?
Yeah, so this one is a complex story. So I actually created the first version, which was Quick SQLite. This was like 3 years ago. And this was just, let's say, the very same existing library that was there for SQLite on React Native, but it just used the JSI, right? So it
Mm-hmm.
just made it faster on the
Mm-hmm.
virtue of using the JSI. There wasn't any clever ideas inside. It was just using the C++ functions, and that just made it faster. And that got fairly popular. But last year I had a little bit of burnout, right? Between work and open source and just life in general. And at the time, we were collaborating with Mark on different projects. So I was like, hey, I cannot take care of this right now. Let me just hand it over to you guys. You guys do a lot of libraries. You have a lot more people than I do. Just take care of it, right? So then at the end of the year, let's say August, November, when I took a very long vacation, then came back, I had a lot more energy. I was just browsing through the quick SQLite issues. There's a lot of technical issues, people asking for features and this kind of stuff. Nothing which to me sounded very appealing to be like, okay, I want to take care of this again. But there was one use case that I found quite interesting, and at the beginning, it kind of not broke my heart, but it just caused some repulsion, which was some people were running very large loads or very large computations on mobile, right? And um, my first reaction after many years of doing React Native was like, why would you want to do this, right? Like, don't do this on a mobile device. This is just wrong, which I think a lot of people still have this impression is like, don't do this on a mobile, right? Like, there's
Yeah.
no point. And then I started to think a little bit about it, and I was like, basically the chip that you have now on your iPhone is the same chip that you have on your Mac. It now has 8 gigabytes of memory or 16, or I don't remember,
Mm.
something like that. It's no longer a small device. It's a proper computer, right? So
Yeah.
if you can do some sort of large computation, you're actually enabled to do more interesting things than just, taking photos and doing dog filters and this kind of stuff. It's fun, sure, but not my cup of tea. So I was like, okay, this use case is actually not as crazy as it sounds. It might enable to do some interesting things. And um, we already had the discussion with Mark and the team to migrate to host objects because a lot of the apps that were using Quick SQLite, they were reaching the performance bottleneck of like, okay, we need to fetch 20,000 records from the database,
Mm-hmm.
and this is just too slow. And at the beginning, I was like, again, no, why would you want to fetch 20,000 records on a mobile device? This is just dumb. Don't do this. But then I had a little bit more time, had more energy. I was feeling like, okay, let's just tackle this challenge and see what happens, right? So I did the migration just as a proof of concept to host objects, which again are these hybrid objects, right? Like they have some
Mm-hmm.
native state with some JavaScript interface. And it's definitely a trade off because the trade off is you get much faster object creation because you're not creating any JavaScript object, but you pay on the access to the data, right?
Mm-hmm.
So JavaScript objects, normal objects, are slow to create from C++ because you tell the JavaScript engine, create this object for me, then it returns, then set this property, yada, yada, yada. With host object is like, here's the C++ object, just send it back to JavaScript. But when you need to access a property, then's when the conversion happens from a C++ scalar to a
Mm-hmm.
JavaScript side of things. So it's definitely a trade-off there. However, if you think about the normal use case of these kind of things, I mean, there's of course going to be crazy people who do computation on the 30,000, on the 300,000 objects at once, and then it's just going to be slow no matter what. But for the apps that just display it on the list, the trade-off is actually very worth it, right? Because you only display 5, 6, 10 elements at once, and the rest, the 290 objects that are there in memory, are not doing anything. So it's a very worthy trade-off for the usual use case. That's why it's so much faster, because I just return the C++ objects to the JavaScript side. If you don't touch them, the response is super fast. Is once you start accessing the properties, that's going to be slower, a little bit slower than normal JavaScript objects. But as long as you don't display the 20,000 of them at the same time, you're going to get a lot of faster response.
I see. Yeah, that definitely makes sense. And from everything you told us before, I think I finally understand a bit more about the hybrid object and what's going on in the background. So it's pretty cool to see like all these concepts coming together in a library, and then when you talk about it, you can finally make sense of like the new architecture and the performance improvements and what the trade-offs A or the trade-offs B might be of a certain library. So I would definitely recommend everyone to check it out. It's called OP-SQLite. I actually haven't used it before, but I think I will definitely do it in the future, as it looks really good from the benchmark. So thank you so much for taking the time today, Oskar. I think this was like this was pretty much the same like talking to Macro Savvy. My head is spinning with all the C++ and Swift and JSI, and I need to sleep some nights over this and to make all the new connections in my brain. If anyone else has the same problem, where can they find more about you and the things you said in this podcast?
You can always find me on Twitter. Lately, I've been too busy to post a lot of stuff, but usually the go-to channel, of course, YouTube, GitHub, everything is under the same nickname, Oskar Franco. So you can just Google it and you will find everything.
Awesome. Thank you so much for all you've done for the React Native community, all the videos and all the libraries, and for taking the time. And maybe we can talk again in the future episode about Rust when it becomes even more popular. So thanks, and until next time. Bye.
See you next time.
Thanks for joining today's episode. My goal is to share interesting stories and insights into the world of React Native development. If you enjoy this show, please subscribe to the show on YouTube, Apple, or Spotify. And on Spotify and Apple, you can leave up to a 5-star review. Because podcasts, and especially niche podcasts like this, are hard to find, subscribing and leaving a review does help me a lot. On top of that, check out my React Native courses on galaxies.dev that cover a variety of topics from getting started to building and publishing your mobile app. Finally, you can share today's episode with a friend or colleague who would enjoy the topic of the show. If you have any questions or ideas for future episodes, find me on X or leave a comment on YouTube. And last but not least, thank you for listening and happy coding, Simon.